Okay, hi everyone. Good evening. My name's Michelle Tyndall and I'm a volunteer with the IET and I'm here to introduce the lecture this evening. So we're joined by Finley Asher this evening, who's a former aerospace engineer who's now working towards a sustainable future for the aviation industry. I've just got a few QR codes here. So one which links to the IET East Midlands YouTube channel where this lecture is being recorded and it'll be uploaded there shortly after the lecture, and maybe a week or so. And then also a link to the organisation that Finley's working with called Safe Landing if you want to find out more. So yeah, I'll hand over to Finley now. Can you just put questions in the Q&A as we go through the lecture, and we'll get to those at the end. Okay, over to you, Finley. I'll stop sharing.
Good evening. Thanks for having me. Yeah, let me just share my screen. So do that. And oh, wrong one. Okay. My screen's gone a little bit slow, so let me know if you can hear me fine. So yeah, thanks for having me. As Michelle was saying, my name's Finley Asher. A little bit about me first. I'm a mechanical aerospace engineer. I'm currently part of this group called Safe Landing, which I'll explain in a second. And I also have a YouTube channel called Green Sky Thinking, which you can check out as well. I spent 7 years at Rolls-Royce, primarily designing future aircraft engine systems. So for example, I was working in the future programs team, looking at future Airbus and Boeing concepts for the 2030s. I've worked on the UltraFan project, so the geared turbofan that Rolls-Royce are developing. We might see that in service around 2030. And also other concepts, more advanced concepts, such as the variable pitch fan that could allow us to go to even higher bypass ratios of engines. So while I was in the company, I formed something that I called an employee sustainability group. And this challenged the corporate sustainability team around their strategy. And we got together and we looked at the various elements of Rolls-Royce's strategy, but also of the industry in general, because there's quite a consistent strategy and messaging, which I'm going to talk you through this evening, and some of the issues with it. And we were basically, what we did as a group is we looked at each of those topics, we went away and researched it, presented it back to each other and to the corporate sustainability group, and sort of said, we see real problems with this, tell us why we're wrong. So I was doing this for about a year or so, and then COVID-19 happened. And I'd been thinking about taking a career break anyway, very passionate about environmentalism. And I thought, you know what, I'll use this opportunity to go and try something else. and get into environmental campaigning. So, particularly last year, we had COP26 in Glasgow. I'm from Scotland. I moved to Glasgow actually, and still there now, and just thought I want to do as much as possible ahead of COP26 to try and get this topic of aviation and what needs to be done about it out there as much as possible. And that's a picture of me in the Highlands with my laptop. So now I run this group called Safe Landing. We're a group of aviation workers, and we're looking to navigate a sustainable future for the industry. So one that is truly sustainable in terms of the planet, but also sustainable in terms of everyone's careers that's in it. Secure, stable employment into the future. How can we achieve that? So we're a group of engineers, pilots, cabin crew, maintenance workers, etc. Anyone related to aviation can join if you care about the environment and you care about the sector and what's going to happen in the future. So I've called this talk Heading for Crash Landing. It's a bit provocative, obviously. So why is that? Well, I think when it comes to the climate crisis, this is going to be something that transforms every aspect of our society, of the economy, and aviation is no different. And really just to highlight that, I don't know if anyone watched the IPCC release their report this week. I was watching the conference and I took this screen grab. So it says, unless there are immediate and deep emissions reductions across all sectors, 1.5 degrees C, which is, very dangerous global warming, is beyond reach. So across all sectors is really important, because I think in aviation, we sometimes feel that we've got this privilege that we're outside, everybody else needs to decarbonize, and we don't. But the message from the scientists is very clear. We need rapid, deep emissions reductions everywhere. And just going sort of forward a slide as well, they did mention as well that a lot of that emissions reduction needs to come from demand management and human behavior. And in particular, they highlighted reducing air travel. So as aviation workers, we need to be aware of that and not kid ourselves about what's coming. So I think it's really important as well to think about timescales. So the carbon budget is something that's really important. So we have a certain amount of carbon that we can put into the atmosphere before we exceed 1.5 degrees C. And if you think about the atmosphere as a bucket, and when we emit CO2, we fill up that bucket. And when we reach the top of the bucket, we've exceeded 1.5 degrees of global warming. We obviously started at the start of the Industrial Revolution about 200 years ago. And ever since, we've been accelerating. Every year we put more CO2 and we're accelerating towards the top of that bucket. We only have about 10 years left before we blow the carbon budget. It doesn't really matter about net zero. It matters about what we do in the next 10 years. And it's really important to have that in context when you're looking at the solutions. So 10 years is like what we need to aim for here. Now, the next thing about reducing emissions is understanding who produces it. This is a really good chart from Oxfam, which show basically the top 10% of by income are responsible for basically 50% of emissions. And the poorest 50% are responsible for a similar amount. So if you want to reduce emissions and reduce them fast, then we need to target high income, high emitters. Very little value of targeting low income, low emitters who barely produce any emissions every year. And obviously flying is something that is done by very high income, high emitters. So I think this is important before we get into technology, is just to touch on the inequality of flying and who does it. So 1% of the world's population produces 50% of commercial aviation emissions. 80% of the world have never set foot on a plane and are not responsible at all. And even in countries like the UK and the US, where we fly a lot more than others, it's still a very, very small proportion. So in the UK, it's like 15% of people produce 70% of emissions. The average person in the UK doesn't even fly in a given year. And those that do usually just do 1 or 2 flights and they don't go very far. So it tends to be the frequent flyers that are really responsible for the emissions. So why do I think we're on a bit of a dangerous trajectory? Well, this is CO2 produced from aviation every year, and it has been exponentially increasing. Particularly over the last 10 years, it was growing at 5% per year. That's with all the efficiency improvements in there. So we think at Safe Landing, this is a dangerous trajectory to be on, and we need to set a new flight path with emissions that are fundamentally reducing every year. Now, the industry doesn't plan to do that. The industry plans to grow, and it has a sustainability playbook, is what I call it, that it uses to justify this future growth. So the first thing it does is it plays down the problem. It says, you know, we're not a big part of global emissions. We're only 2%, we're only 3% of global CO2. Now that doesn't seem like much, but actually that's more than the entire emissions of Britain, Mexico, or Brazil. And actually it's the trajectory that's important. So other sectors are going to decarbonize, but the aviation industry doesn't really have a good path to zero emissions. And it's projected that by 2050, it's going to be using up 25% of the carbon budget, which is obviously a large share, particularly given how few people do it. The next problem is this isn't just about CO2. CO2 is only 1/3 of aviation's impact. The non-CO2 emissions, so we've got contrails, in particular, the water vapor and cirrus clouds behind the aircraft actually contribute 2/3 to aviation's global warming impact. So actually those numbers, you know, you need to basically double them. So there are 4 pillars to the sustainable aviation narrative. The first one is efficiency improvements. We say, you know, fuel burn's getting better every year. Fuel burn per passenger mile traveled is less, and therefore emissions are going down. The next thing is electric aircraft. The next is sustainable aviation fuels, so just including hydrogen in there as well, I suppose, but biofuels and e-fuels, and then carbon offsetting as a policy. So I'm going to touch on each of these in turn. So the first one is aircraft efficiency. And obviously I was working on jet engines, and that's a big part of improving the efficiency of aircraft alongside the aerodynamics of the wings and the fuselage and lighter materials, etc. Now, when you look at efficiency over the last 50 years, that the light blue line, kilograms of CO2 produced per passenger kilometre, that has been reducing, although it is starting to level off, and we are struggling to get more efficiency improvements in the future, which is exactly what I was working on. But the problem is, at the same time, we've had this is trillion passenger kilometres per year, and that has been massively increasing. And that's partly driven by the efficiency improvements. It's cheaper to fly, more people do fly. The result of that is, despite the efficiency improvements, we're getting this aviation CO2 growth that's rising rapidly. So the efficiency improvements alone can't decarbonize the sector. You know, it's a bit like saying with cars, like rather than switch to electric cars, let's just keep on making petrol and diesel engines more efficient. That isn't working. So historic aircraft efficiency improvements have led to total emissions increasing, not decreasing. And obviously, this will continue into the future unless we constrain air traffic growth in some way. So we're going to see a rebound from COVID, air traffic recover. Airbus and Boeing are both predicting that we're going to double the number of aircraft over the next 15, 20 years, and that will lead to emissions increasing. Okay, so what can we do? Alternative technology. So the first thing is electric aircraft. Now, really, these are only viable for very small aircraft. So, you know, we're looking at 10 passengers flying very short distances. So we're looking at, you know, maybe an hour or two in an aircraft that's very small and not really carrying many people. And when you look at those distances, really, a lot of the time, there's a ground transport option, a train, a coach, a ferry, that's a more efficient use of electricity. That's not to say that there's some niche cases where electric aircraft would be useful, Scottish Highlands and Islands, Norway, where it's very mountainous. I'm not saying we shouldn't have electric aircraft, but they're very limited in their ability to decarbonize the majority of flying, which is done in bigger aircraft, big distances. And the big difficulty here is really the weight of the electrical systems. This is a chart from Airbus. It's basically saying batteries are 50 times worse than jet fuel on a mass basis, really. Electric motors are more efficient, so that brings it down somewhat, but we're still about 25 times worse. And the other problem is, obviously, when you burn jet fuel, your aircraft reduces in weight as you fly, and that gives you a performance benefit. With batteries, they discharge, they don't lose weight, and the landing weight of the aircraft is the same as the takeoff weight, and that gives them a further impact onto their capability. So the next is hydrogen flight. Now, hydrogen looks good on a mass basis. 1 kilogram of hydrogen is about 120 megajoules of energy compared to 44 for jet fuel and less than 1 for batteries. So this is looking pretty good, 3 times the energy per kilogram. The problem with hydrogen is its volume. So basically, it's a quarter. Within 1 liter of hydrogen, you've got a quarter of the energy that you have in jet fuel, which means if you've got a storage tank, you need 4 times the storage space. The other problem with hydrogen is that because you need to cool it to cryogenic temperatures and pressures, you end up putting them in very cylindrical storage tanks. They don't fit in the wings, you have to put them in the fuselage, and that means you need to radically change your aircraft architecture as well. Now, either you put them in the fuselage and you expand the size of the fuselage and increase the aircraft weight and drag, or you put it inside the fuselage and you get rid of passengers. Both of these things are going to make the aircraft less efficient, or they're going to allow you to carry less passengers, requires you to use more energy, and that's all going to put costs up. It's possible, but we're going to have to travel less or use more energy in order to do this. So just to sum up on hydrogen flight, and then the other aspect is just like it means you can't go as far as jet fuel. So it's only really viable for medium aircraft flying sort of medium distances, and we'll probably see it at the smaller range as well to begin with, and that will scale up. But the big issue really with hydrogen is just the timescales. So because the jet engines need to be different, the aircraft design needs to be different, we still haven't figured out the best configuration. We're looking at 15, 20 years, the late 2030s, before we see these enter service, and then they won't get any significant market penetration for a long time after that. So this is kind of like possibly a good way of flying in the future. We should be developing them, but it's not helping with the next 10 years, the next 10 critical years that we need to look at. And then, yeah, it requires very different aircraft and airports, and we need to reconfigure those, and we're not really doing that at the moment, and it requires huge amounts of energy, well, which I'll get onto in a future slide when I look at synthetic fuels. So, okay, the next is alternative jet fuels. The industry calls these sustainable aviation fuels, and the idea with this is that at the moment we extract fossil fuel from deep underground, hydrocarbons that are stored there, we refine them, and we burn them in a power station or in our car or in an aircraft, and we release greenhouse gas and CO2, and we're adding CO2 to the atmosphere. Well, instead, what we could do is we could take carbon that's already in the atmosphere by growing crops and plant matter to create biofuel. We could also get water and through electrolysis, produce hydrogen, or we could suck carbon directly from the atmosphere with an industrial process like direct air capture to get carbon. And if we combine the carbon with the hydrogen, we can get a hydrocarbon, and we can burn that instead. And we've got this, regenerative cycle, apparently, where we're not adding any additional carbon to the atmosphere. If we power that with renewable energy, we could say, oh, this is a zero emissions process. So let's have a look at those. Okay, the first thing I wanted to touch on was just the industry targets. So if we have a look at history on this, back in 2008, the industry, and this was IATA, was projecting we'd have 10% jet fuel by 2017. Then later on, 2010, they had a 2020 target of about 7%. And then later now, we're now proposing a 2025 target of 2%. And actually, our use has barely scraped. It's like 0.05% of total fuel burn. So we've got a history over the last 15 years of promising big, on alternative jet fuels and not delivering. So this raises the issue of trust when we're looking at 2030 targets and onwards, and we're targeting 10–15% again. So let's look at biofuels first. The idea with biofuels, as I was saying, is you basically you grow crops or trees, sequester carbon from the atmosphere, create a fuel that can then be burned in a car that returns the carbon to the air, which is then resequestered by the crops. And you've got this kind of circle of life where you're not adding anything additional to the atmosphere. Now, I'm going to say this is actually a circle of strife, and biofuels are a very, very dangerous path to go down. And I'll just outline some of the issues here. So the first is fuel from crops. Now, what's been shown when you look at pretty much any crop that's grown, particularly palm, particularly soy, is that actually the land use change emissions resulting from deforestation, from increased agriculture, draining peat bogs, water pollution, insecticide, etc. These lead to biodiversity loss and land use change that leads to CO2 emissions that are actually worse than fossil fuel. Now, the industry does say it won't use fuel from crops, but that isn't in the legislation at the moment. And actually, there's lots of examples of SAF that's being built and is using crops. So, for example, I actually helped with this project. This is a recent one that was released, looking at something called the Omega Green biofuel refinery in Paraguay. This is the biggest refinery, sustainable aviation fuel refinery in the Southern Hemisphere. It's not been built yet. It's going to produce millions of litres of SAF for BP and Shell, all to be exported to the EU and the US. And it's going to basically run on soy and animal fat from deforested rainforest areas. And Paraguay, the Chaco region, is already one of the most deforested regions in the world. It's already lost 40% of its trees, and it's estimated that by 2030, it will have lost 70% of that. So this is adding to that, and we need to have our eyes open to the environmental impact, but also the humanitarian impact. We're talking to the human rights groups on the ground, and we're seeing land grabs, we're seeing increased pollution for those local populations. So then the next thing the industry says is, well, what we'll do is we won't have fuel from crops. We'll use waste streams from forestry or from agriculture, etc. Now, the problem with this is there is multiple competing uses for all of these things, and there's displacement effects. And the other problem is we haven't actually commercially demonstrated at any significant scale any of these. We've been trying for quite a while, and it's not happened. But even when we do look at, let's just say that all of these processes turn out, it's been shown that we've really not got enough feedstock to meet aviation energy demand in 2050, potentially supplying 10% of demand in 2050. And this is from transport and environment. So we're going to need to look elsewhere. So the summary here with biofuel really is that agricultural crops can't be scaled sustainably. They impact land use and water use. We've got household waste, which can't be scaled as there's not enough waste. And forestry and agricultural waste can't be scaled either, as we don't have enough waste. And we can also end up removing carbon from the soils, which is a good store of carbon to stop it ending back up in the atmosphere in the first place. Obviously, with household waste, etc., we want to be minimizing waste, going to a circular economy anyway, and not incentivizing us to continue wasteful habits. So biofuels, I'd encourage us in a kind of simplistic way to say, let's rule that out. So the next thing is synthetic electrofuels or power to liquid. And the idea is that this is all produced from renewable electricity. We've got electrolysis of water to produce hydrogen, and we've got direct air capture, which industrially takes carbon from the air. You put those two things together and you get a hydrocarbon electrofuel that you can put in your aircraft. Now, the problem with this is how energy intensive all of these processes are. And you can do some calculations. And basically, if you look at the UK, in 2018, we used 12 million tons of jet fuel. Now, using a relatively kind of optimistic efficiency, to produce that in synthetic fuel would need 250 terawatt hours of energy. Now, the UK grid in 2018 only produced 330 terawatt hours all year. So you basically need 2/3 of the total grid. Renewable generation was 110. So you need twice that. And obviously right now at the moment, we're talking about scaling up offshore wind, building more nuclear, etc. But we're going to need a large proportion of that just to produce e-fuel. And this raises the question of, is that a good use of our limited renewable electricity? Because it feels like we're making a lot of progress with wind and solar, but this is global human energy consumption over the past 100 years. And it's mostly biomass, coal, oil, and gas, and solar and wind are barely noticeable on there. Solar is 1% and wind is 2% of current global consumption. So we barely got any low carbon energy. It's a very scarce resource at the moment. And if we keep on increasing energy consumption, we're just going to drive more fossil fuel consumption, even if we're growing renewables. So we need to be very mindful of how we use that energy and make sure we don't use it for inefficient things. So let's have a look at, if we have 1 megawatt hour of renewable energy, what could we use it for? Sorry, this graph isn't the most readable, but basically the first one is displaced coal generation. This is from the UK Committee on Climate Change, and you could save almost 1 ton of CO2. The next best thing you can do is power an EV, an electric car. The next thing is to power a heat pump to heat home. Then you can displace gas generation on the grid as well. Next thing is power direct air capture to resequester CO2. The next is hydrogen boilers. So again, very inefficient, but even worse is producing synthetic jet fuel. So literally it's one of the least efficient methods to use renewable energy to decarbonize our economy. So whenever you think about using 1 megawatt hour for synthetic jet fuel, you got to remember, if you're still got petrol and diesel cars driving around or gas boilers in our home, you've got an opportunity loss of using that energy for producing jet fuel rather than that. And actually, if you take a holistic cross-economy approach, we're actually increasing emissions by diverting that energy somewhere else. So final thing is carbon offsetting. And the principle with this is obviously some people fly, they increase their emissions and they feel better about it because they pay somebody else to reduce theirs. Now, in terms of aviation, you've got 2 things. You've got the UK or EU emissions trading scheme, which covers the UK and Europe. Now, the problem with this is we've got loads of free allowances. So this is the top 10 airlines. The blue is their CO2 emissions and the orange is their free allowances. And you can see that there's a lot of airlines that don't emit more than their free allowance and don't pay anything. And most airlines like Ryanair do pay some, but they're not paying for the majority. So there's not actually full coverage at the moment. And these emissions pricing is actually quite cheap as well. But what's kind of worse is the CORSIA scheme, which covers all of international flights, extra EU outside of the EU. So the CORSIA scheme stands for the Carbon Offsetting and Reduction Scheme for International Aviation. Now, the problem with this is there's a baseline in CORSIA and it's 2019, which means we've been increasing emissions up to 2019, and then we set to 2019 level. And we've said we'll only offset and pay for emissions that go above that level. So obviously we've got COVID rebound at the moment, and we're going to be below. And then only when we exceed 2019, we're going to offset and pay for it. So there's a large chunk of emissions that aren't going to be offset, and that's just CO2. The other problem is that non-CO2, which is 2/3 of the impact, aren't accounted for at all in either the UK ETS or the CORSIA scheme. Now, this is just a video from one of my YouTube videos, but if you look at the cost of these offsets, the EU ETS is about 45 euros. CORSIA, it's down at like $1 at the moment, and it might rise to about $10. But the cost of industrial carbon capture, the cost of future generations of actually removing these emissions, is closer to $1,000 or like £800 at the moment. It might come down to £500 in the next 20 years. It might come down to £200 by 2050, but it's a lot higher than this cost. And obviously that's spread across the effective price, because people aren't paying for all of the emissions, is a lot lower again. So basically this is us putting a debt onto future generations who are going to have to pay to resequester the emissions over the rest of the century. So just a summary in carbon offsetting: far too weak, the credits are far too cheap, and the credit systems don't actually apply to the vast majority of aircraft emissions. So what policies do I think are required, just to start to wrap up? And I know I've kind of jumped through a load of things here, but there's a lot kind of going on with aviation, a lot to cover in half an hour. So what's my opinion on what policies are required? So I think the first thing is that we need to actually account for aviation emissions. Most countries under the Paris Agreement submit nationally determined contributions, which are the emissions that they promise that they'll emit. And generally, they don't include international aviation emissions. The UK's promised to in the 2030s, but that's kind of leading the way, and most countries don't, and we're not doing so over the next 10 years. So what I think is we need to include international aviation emissions in our accounting as a basic first thing, and that should include non-CO2 impacts as well as CO2. I think emissions pricing is required. Particularly, we could use a fuel tax on fossil fuel kerosene, and we need a clear roadmap of increasing price over the next few decades to give the industry certainty, and so that we don't expand business as usual beyond what's expected. And this was a big thing when I was working in the sector and looking at future programs for the 2030s. We were assuming a super low price for jet fuel. It was just going to stay really low. We're going to keep on emitting and have lots of cheap, low-cost carriers, and nothing is going to change, which isn't really looking at the reality of the climate crisis and what's required. We could also use progressive policies such as a frequent flyer levy. So the more you emit, the more you pay, like an income tax that it's got thresholds you pass and then you pay more. And that would mean that the wealthiest, highest emitters are paying the most. I think we should have a minimum use of biofuels for aviation. We really risk exacerbating the climate crisis if we try and target too high biofuel use. And I think offset should only be used as a damage mitigation and not as a solution that stops us actually reducing emissions in the first place. And then finally, I think it's kind of going to be inevitable that we have to constrain how much we fly, particularly in high emitting countries like the UK, where we already fly a lot more than others. So how do I think we can achieve that? I think we should challenge false solutions, greenwash, where we're looking at shiny technology that's going to save things rather than regulations. I think we need real solutions, and we need to look at policies. And I think, the people that are in charge, politicians and industrial leaders, don't want to look at policies because they will restrict growth, and that's fundamentally what they're against. But this is leading us towards a cliff edge where those policies are inevitable, and that could have a real impact to the industry and to workers within the industry. So I think what we need is citizen-led and worker-led movements to push for those policies, because they're in all our best interests in terms of preserving the ability to fly into the future for future generations, and then fundamentally preserving the ability to have safe, secure employment within aviation over the next 30 years. And then I think we need to prepare ourselves for change, how the industry needs to adapt, and start doing it, because we really don't have time. So yeah, just this is a slide that we show at Safe Landing. We've had historic growth that's been kind of exponential of air traffic. We've had the COVID-19 crash, where we've seen a big reduction in air traffic, and that's not been good for workers. There's been a lot of fire and rehire, a lot of redundancies, but the industry just wants to get back onto that business as usual growth trajectory. If we then have a sudden cliff edge of policies, we're going to have a climate crash, and that isn't going to be good. We might have short-term jobs over the next 10 years, but long-term, we just hit a brick wall and suddenly we lose all moral license to fly. Then we'll have a climate crash, and that'll be really dangerous for workers. And then we'll have to rebuild from that point with zero emissions aircraft. We're proposing a safer trajectory where we constrain how much we fly in the short term, in order to avoid an industry crash and start adapting ourselves as early as possible so that we can minimize and smooth out that process. Yeah, so I think I'm going to leave it there because I've got some other slides, but I'm conscious I want to open it up to questions and answers. So thanks for listening, and I look forward to hearing some questions.
Yeah, thanks a lot, Finley. I'll give you a little round of applause because there normally would be one in a lecture theatre if this was in person. And yeah, there's quite a few questions come in, so I'll just start at the top. First one, how is Safe Landing funded, which is interesting to understand.
I don't. Yeah. So after I quit my job, I was basically unemployed for a year and a half. So I was doing it, just living in my mum's house, not making any money, and helping different community groups that were working on stuff. And started the group on a voluntary basis with other people where we're just doing it. We did get some funding recently from Patagonia, who have the clothing company, who have a charity pot, and also from a NGO called Climate Works that fund various NGOs in this space as well, because they see the benefit of engaging workers in these policy conversations.
Good, okay. Next question. I'm interested to know, when your RR internal group asked your employer, tell us what we're getting wrong. Oh, sorry, tell us what we're getting wrong. Yeah, what was their answer?
Well, I think it's difficult, it's difficult for them to answer, actually. Like a lot of the stuff we're discussing is physics and it's economics, and really, I actually, like, when pushed, like senior leadership were saying there will be emissions pricing, but we don't think politically politicians are going to do it, and people don't want to pay more to travel. But that's kind of, to me, is ignoring the inevitability of what's going to happen, and I thought it was dangerous. When I pushed the chief technology officer on biofuels, on carbon offsetting, they agreed with me that we can't scale biofuels beyond a certain amount, that the CORSIA scheme is weak and flawed and not good enough. They proposed we just make e-fuels from nuclear power. Now, some people might be thinking that sounds like a good idea, okay, but again, we need to look at the timescales. So how long does a nuclear power station take to build, even if you think nuclear power is great and you're not concerned about safety, or any of those issues? Just say we want to build it, let's get building it now. It's going to take decades to build enough nuclear power to make e-fuels just for aviation. I did a calculation using using just like some data that Rolls-Royce had for small modular reactors, how much synthetic fuel they could make, and basically calculated we need $4 trillion as well to build all of those reactors. So, okay, maybe it's possible, but it's not going to happen overnight, building $4 trillion worth of nuclear power stations. And if that is going to happen, it's a bit ridiculous to say that flying can remain cheap. So there's a big tension between this thing that's like, we're going to have nuclear powered e-fuel, and somehow we're still going to fly to the other side of Europe for £10. And yeah, they basically found it pretty difficult to come back to that.
Okay, I can see there's a few people putting questions in the chat. I'm going to go through all the questions in the Q&A first, and then I'll scan over it. But if you can put it in the Q&A, then that'd be helpful, and we'll get to everyone's questions. Next question. So do you see a future for liquid ammonia fuel as a source of hydrogen?
From what I've read, I don't think so. I think it's also got volume constraints that are similar. It's better in some properties to hydrogen. It's easier to store because it doesn't need to be cryogenic, but then it's similarly got storage issues, and also it's like really dangerous to handle, and various other things. So I have seen studies, but I haven't seen any like really serious suggestions from any of the aerospace manufacturers that it would work. And yeah, I think there's some like key technical hurdles that haven't been overcome. I'd more expect ammonia to be used in shipping because the volume and weight constraints aren't as bad.
Yeah. Okay. So a number of years ago, someone attended an IET talk about an all-electric aircraft concept from Rolls-Royce, done with Cranfield, that used superconducting power transmission with an onboard cryogenic cooling system to bring the weight of the cabling down. Did you heard of that?
Yeah, so basically, because of the weight of electrical systems, the way that you can massively reduce the weight is to make them really low temperature, and then you can shrink the cables and the motors and everything. But I get, like, it's very far, like, I'm sure as well, if we introduce hydrogen, we can use the fact that hydrogen is cold to improve heat exchangers and maybe run some of the electrical systems colder as well, which will give a benefit. Again, it's just the timescales. Like, some of this stuff's going to happen, but it's not going to happen in the next 15 years, and cryogenic stuff's further out. So yeah, it's probably necessary to make electrical flight work, but will it happen in the next 15 years? No.
Yeah, so this is probably a question on similar lines. So is nuclear fusion the only realistic energy source for present and future energy demand?
It's not been demonstrated yet, so we can't rely on it for the future of humanity. That's the short answer.
Yeah, I work in fusion and I agree. Lobbying into governing bodies, how is it going, and are your views supported by the industry to support adoption?
I think it's interesting. I think like, a lot of people are saying the right things, and a lot of unions are thinking the right way to an extent, but they tend to buy into the industry greenwash. It's very pervasive amongst politicians and people in the industry of, like, sustainable aviation fuels is the way forward. All it needs is government funding. There's this kind of concept that taxpayers should fund and subsidize sustainable aviation fuels, and air travelers shouldn't pay for it, which is a little bit strange. And we will need, basically, like, just IATA are saying we will, in the 2030s, we'll need to be spending about 100 billion per year on biofuel refineries. So the thing about this for me is just like, is it realistic to assume that the public, the taxpayers who majority don't fly, will be subsidizing that amount? And you kind of get into that detailed debate with them. And the idea that maybe regulations aren't the way forward, we need to deregulate and make money. So we're having some interesting conversations, but I think, like, fundamentally, unions are starting to realize that, like, they are realizing that the climate issue is the jobs issue, and that the industry will transform, and they need to be at the forefront of that thinking, where the transition will be done to them rather than by them. So I think it's only starting to get there, but yeah, hopefully more and more we'll see unions starting to challenge the narrative of industry leaders.
A bit more of a technical question. So could you provide a reference for the non-CO2 emissions of aviation? I've heard that they are twice the basic CO2 emissions, but have never really understood it.
Yeah, so I've stopped sharing my screen, haven't I?
Yeah.
Basically, David Lee 2020 contribution of aviation to, and for, yeah, it's in my slide pack. If you're sharing the slide pack, I've got a lot of references, so you'll be able to find that.
Yeah, I can probably send the slide pack around afterwards. Yeah.
Yeah, but basically, David Lee 2020 paper has got it in the abstract in it. If you have a look at the different elements of the non-CO2, because it's quite a lot and it's quite confusing. Like, the biggest by far is the contrail cirrus, and that is caused by soot particles from the exhaust, in particular weather regions. So there's kind of two things you can do. You can minimize soot from the engine, and that is by using alternative fuels that burn cleaner, but we don't have much of them. Or you can fly around the weather pattern, but you end up burning more fuel, and that's a difficult one to do. So the thing to bear in mind with non-CO2 is, if we fly less, we will be burning less CO2 and we'll be producing less non-CO2. And also we'll need less fuel. So the alternative fuels that we do have will go further. and there'll be less aircraft in the sky, and it'll be easier to reroute around weather patterns. So it's kind of a complicated science, but the solution to it is relatively straightforward.
Okay. Yeah, I'll make sure we send something around about that at least. Okay, so what can air forces with fast jets do to find sustainability improvements? So obviously air power does need to be maintained, but does carbon need to be considered?
Yeah, I mean, the military is saying the same thing, right? They're saying they're going to use sustainable aviation fuels, but the military uses so much that they use like the entire global supply. So I mean, I don't really have an answer to that, other than we'd obviously need to do less in general. If you're saying you can use it for the military, okay, but there's an even lower amount of SAF to go around. Obviously, world peace would be would be good as well.
Yeah, but do you know what proportion of aviation emissions come from defence or
well, it depends if it's global. It depends if
things.
it's global or it's so the US is huge. The UK is decent sized. I did contribute to an article on this, and I could try and find the facts, but I don't have it off the top of my head. I do know, I think if they did use SAF, they'd use like all of it.
Okay.
Yeah.
Just someone saying, very good presentation, best energy derived carbon release that I've ever seen. Well done, Finley. So that's not a question, but I'll read it out anyway. There are lots of nice comments as well in the chat, so I will get those to you. Okay, another one. So regarding hydrogen aviation, does that address the contrail issue that you said is kind of bigger than the fuel?
So yeah, it basically, hydrogen produces no soot, so it doesn't produce the contrail cirrus, it doesn't produce CO2. It does still produce NOx, which is a greenhouse gas. We can redesign the combustors for lower NOx, but that's part of why we need to redesign the engines, and that's going to take so long. There will still be some NOx, which is a greenhouse gas, so it's not zero emissions, despite Airbus saying zero emissions aircraft. There will definitely be NOx and also water vapor, which also has a global warming impact, depending on the altitude that you're at. So potentially, if we had hydrogen aircraft and flew them at a relatively low altitude, like turboprops do, you might have low non-CO2, but it is a big uncertainty. And the fact that non-CO2 isn't regulated means it's a bit difficult to design a hydrogen aircraft at the moment, because you don't really know what the cost benefit of different emissions are, because we basically ignore anything that's not CO2 at the moment, or NOx. So basically, yeah, I think hydrogen will in general be a non-CO2 improvement, but it won't completely eliminate it. And the uncertainty is part of what makes it challenging to design hydrogen aircraft.
Yeah. Okay. I will try and get this question across. So if 1 megawatt of energy can save 10 times the CO2 in displacing coal versus making sustainable aviation fuels, so why not double the cost of jet fuel and spend that extra money to displace coal, basically, or make homes more efficient? I mean, I guess it's just saying we should tax aviation fuel, which you'd agree with.
Yeah, I'd Mark Ward, I'd 100% agree with your suggestion. It sounds like a very sensible idea. You might just, yeah. So just for context, if we tax jet fuel at the same rate that we tax petrol and diesel at the fuel pump for motorists in the UK, we could raise about 10 billion a year. And obviously, it's relatively high income, high emitters that would be paying most of that. We could obviously use that money for insulating homes, for subsidizing electric public transport, the NHS, etc., and renewables, all things that provide lots of jobs and have wide distribution effects. But we're not doing that, so that's part of what I'm advocating for. So I think that's a good suggestion.
Is that in the power though for the UK government to do?
It is for so it is for domestic. It is for depending within the EU, and and actually, like, we could do it internationally if we wanted to. There's a question over, though, is the UK showing up internationally advocating for a jet fuel tax when it flies more than the majority of other countries around the world and we benefit the least? So probably not. So
Yeah.
there is, it could be doing a lot more, and I believe that we should be entering bilateral agreements with other countries, because it's difficult to bring there is obviously some countries around the world that are very dependent on fossil fuel, and at ICAO they oppose stuff like emissions pricing and jet fuel tax, and I think to get around that, because it's always watered down, we should look at bilateral agreements with other countries where we start to increase jet fuel tax.
Yeah. Okay. So you propose limiting to today's emissions. If we were to stop all carbon release today, how long would it take to stop climate warming?
Well, I mean,
go into that.
So we need, but basically we need to halve emissions in the net by 2030, and then we need to basically 75% reduction by 2035, and we need to be very low down at 2040. And look at the climate science, like we might have already blown our budget for 1.5 degrees C because there's inertia in the system and there's feedback loops. So it might be that if we stopped emitting today, we'd still get quite severe global warming. But obviously, the sooner we put on the brakes, the better the potential to minimize that damage is. So, yeah.
Yeah, okay. We've got another question from Stephen, who says, so when he's flown recently, he's purchased a carbon offset, which is the gold standard schemes like Atmosphere. Are these more realistically priced than the mandatory schemes?
Yeah, so I've heard of Atmosphere. They're relatively good. I think it's about £25 per tonne rather than like £5. And obviously you get what you pay for. It's more likely if you pay more, you get a higher quality offset. It still doesn't compare to, if you look at carbon capture, it's going to cost multiple hundreds of pounds. So again, it's like a good damage mitigation thing to do, but it's not like, we're also running out of land on the planet to reforest. So it's, and the Committee on Climate Change are basically saying, like, we need to very quickly get away from carbon offsetting and towards actual removals, greenhouse gas removals. And they're like, their factor of 10, 20, 30 times higher than even the Atmosphere higher cost. So good, but not as expensive as it should be.
Okay. We've got a comment here. So a robust scientific presentation, thank you. The focus that underpins effective change is political. Citizen/work-led actions will depend on party political engagement and is outside any domestic agenda. How should we push the issue without pursuing a personal shaming path?
Yeah, so first thing is, I don't think it is effective to shame people for flying, particularly not when, like, I've flown myself, like, and it would be a bit hypocritical, and it just is not an effective means to get change, is to make people feel bad about themselves. It's very negative and it doesn't make people feel empowered. So you do need to talk about the positive things that will come out of change. And one of the big positive things is we stop environmental destruction. We've got a future, but also we can, most people that work in the aviation sector are really proud of the industry. And it's about how can we remain proud into the future? How can we actually, be kind of pilots of our own destiny in terms of the future of the sector? And if we're honest about the impact and we are actually telling the truth about what we need to do and we're getting on with it, I think we will feel good. So there's a positive story to tell in that, and actually there's a lot of work that needs to be done transforming the sector. So it's not like we're going to have any less jobs. It's actually a really positive job story if the companies are willing to pay for the transformation. Okay. And I think that's what should appeal to unions, and then obviously to any labour-based political parties that are engaging with trade unions.
I've got a question from someone called Andrew commented about the about, I think, some carbon capture, but could you comment on some kind of temperature mitigation with mirrors? Have you heard of something called MIA, which is an acronym, reflection?
Sounds like solar radiation management, like for reflecting, well, we're getting a bit outside of aviation right and into so I like basically like they're as risky as they are. If we're relying on mirrors to reflect light back into space, then I think we're at a pretty bad point. We should be trying to avoid that at all costs, but nothing's stopping people researching it, because we might well need it.
Yeah, I guess there's a lot of future technologies, isn't there, that could come into play. I've seen a few comments of people saying that they'd like to see the recording, and yeah, it's going to come up onto the IET East Midlands YouTube channel, but I will send a link round as well to anyone who had registered, so you should get that in the coming weeks. And yeah, we're coming up to about an hour, but are you all right to take a few more questions, Finlay?
Yeah, absolutely. Yeah.
But yeah, if anyone needs to sign off, then obviously feel free to, but we'll just keep going with a few more questions. How does the increased manufacturing energy requirements, including material generation, end of life disposal, to sustain the proposed growth feature in your arguments? Is that in your figures, do you think?
Do you mean manufacturing of
talking about for aerospace growth?
Well, I think so. Basically, the emissions of manufacturing aircraft are relatively low compared to their operational emissions.
Yeah.
Like we're looking at small percentages, so it's really operationally how much we're flying, how much fuel we're burning, that's the big factor. It would, if when we're looking at electric aircraft, you've obviously got big on just electric vehicles in general, we've got huge manufacturing emissions from creating the batteries in the first place, and also like we will end up having to build lots of renewables to charge them, where nuclear power has got emissions when you build the infrastructure in the first place and all. So there is no generation that is zero emissions, there's no manufacturing. And if we're increasing energy consumption, we're gonna be increasing the use of high carbon energy. So really, like when we look at ground transport, we need to minimize the amount of personal vehicles we've got. Electric cars are good, they're better than fossil fuel, but if we end up manufacturing too many electric vehicles, we're going to use so much energy that we're also going to blow the carbon budget. So that really puts into question whether we should be having electric aircraft that are more inefficient than the ground-based electric vehicles, and they charge and discharge a lot faster, and they're less efficient in terms of kilowatt hours per kilometer. So so equally, like even if we had electric aircraft that could fly loads and we built loads of those, we'd probably be equally like not solving the problem. And particularly electrical vertical takeoff and landing, eVTOL, particularly energy intensive in takeoff and landing, and not very aerodynamic in cruise. So that leads me to think that eVTOL is not a very sustainable solution either. Electric aircraft, we should look at fixed wing, more efficient flying. I know that's a bit of a tangent, but I think like the manufacturing of the batteries and the energy consumption of charging them is going to lead to a lot of emissions. Yeah,
definitely. Okay. What do you think about the contributions of air cargo? Is that projected to increase as well? I guess so.
Yeah, it is, and there's more. Like we're buying more and more stuff, and we're expecting it just in time delivered from the other side of the world. So it's actually it's increased because of COVID and people ordering stuff, and more people having access to the internet and buying things online. And there's stuff like you buy blueberries in Scotland. We can grow blueberries in Scotland, but we're buying them in winter from Peru, and they're being shipped over. It's perishable. We could just eat seasonally and get rid of that. But also you just see like clothes being sent, and there's no reason why you can't put it in a boat if you're just willing to wait. So we do need to, in general, decelerate our lifestyles when it comes to leisure, holiday, but also when it comes to consumerism in general.
Yeah.
And like emissions pricing, jet fuel tax would equally mean that people would think twice before they ordered things from the other side of the world and wanted it within a day. Yeah. So those policies would help with cargo as well as passengers.
Okay, another question on hydrogen is are there other technologies available to increase the energy density? Are there like different storage methods?
Like, no, you kind of, the problem is just the fundamental characteristics of it. You can't compress it more than a liquid. Now there is like tank design, like the tank, because the tank is then big, the tank weighs a lot. If you can use carbon fiber or other advanced materials for the tank and shapes, you can get its gravimetric index down. But there's like a theoretical limit to that, right? And you're just limited by, you can't compress hydrogen any further. So it's got a limit that we know that we know what we were being optimistic when we select a tank size for a future aircraft.
Yeah. Okay. A comment about the frequent flyer tax. So someone saying they don't think it will work as you've stated, because the wealthiest 1% are responsible for the lion's share of emissions, therefore they can pay their way around the tax. A personal limit will need applying, or you just punish those who can no longer afford to fly.
Yeah, so just on that first part, this whole point of the frequent flyer tax is that you could actually have a tax-free allowance, so people could, or you know, like a lot lower cost, and then it ramps up. So if you fly once a year, you pay a bit more tax. If you fly twice, like roughly, like it matters more how much fuel you burn. Like a flight to Australia is a lot worse than a flight to Spain. But if it goes up with how much you burn, then you will get the financial burden shifted onto frequent flyers rather than infrequent flyers. Yeah. And that gets around this problem of like access. You should also allow a more distributed access to aviation rather than it being weighted just to like predominantly frequent flyers flying the most and using the most emissions.
Yeah. Okay. Yeah, someone I had seen this question earlier in the chat. So they liked your policies you suggest for the future, but I'm not sure what the third one was, but could you elaborate a bit more about how that could be possible to measure? So I'm not sure what this was on one of your last slides.
The policies part, what was it, the third one?
Third one.
So citizen-led and worker-led movements.
Yeah.
Yeah, well, actually, there is one slide I didn't show, which I think is quite important. It's a cartoon, so it's not much more, but let me just screen. So big problem we've got is corporate leaders are just thinking a year ahead. They're thinking about quarterly profits. They're going to retire, take a leaving bonus in a few years' time, and they're not going to be around when the climate crisis hits and forces a rapid transition. So when you look at a corporate leader, they're not being incentivized to think long term. They're being incentivized to think short term, cut costs in the short term, and push costs onto future generations when they're not going to be around anymore. So the system's not set up to have them think and care about this. Whereas obviously as workers, I'm 30, I might want a job for another 30, 40 years. So I'm going to be working through the transition to a low carbon economy. And it really matters that that happens in a smooth, organized, transitional way, rather like by design rather than by disaster. And the same is true when you think about political leaders. They care about the next election in a few years' time. They're not really incentivized to think about what's going to happen in the 2030s. But as citizens, we're going to be around for the rest of our lives and we're going to suffer the consequences. So this is why citizen-led movements and worker-led movements are really important to overcome this issue of time horizon that political and corporate leaders have. So I don't know, hopefully that answers the question about why I think it's important. And then in terms of citizen-led movements, I think, you know, the right to protest and get out on the street, the demand for citizens' assemblies so that citizens can be involved in participatory decision-making, where being informed by specialists, and producing recommendations to give to political leaders so that they can make those long-term decisions. And I think the same needs to happen within trade unions. We need to be thinking actually workers need to have a different strategy to industry leaders. We don't trust them when it comes to pay, to working conditions, sick and holiday leave and all sorts of things, but we trust them unconditionally on sustainability strategy. Do trade unions not need to develop their own vision, alternative visions for the future of air travel, adopt those as union policies and try and push leaders into thinking a bit more long term?
Yeah. Okay. Okay, I'm just going to scan over because I think we have been going. There's quite a few people saying, yeah, great talk, very well presented, big on facts, small on motives, and wonderfully wide ranging. My eyes were already open, but I opened a bit wider. Many thanks. Let's just check through. I think we've kind of covered most of the topics that people have asked questions about. So I think, yeah, we'll leave it there for me, if that's all right.
No worries. There was someone that mentioned biofuels, and they did a PhD on or postgrad on biofuels that are more efficient. Just looking at the timescales, there is actually only one commercialized biofuel process, and that's waste oil and fat conversion. And that's the only one that we can realistically scale up in the next 10 years. There are a few other, like there's a lot of other pathways that use the waste feedstocks, but we've not demonstrated any at significant commercial scale. And just infrastructure project, the first thing is they actually use a lot of energy. The reason why we haven't built and demonstrated any commercially is because we've been trying and it's not been working, or it's been so expensive because we had to put so much energy in. And fundamentally, some of these waste streams are just difficult to process. So there's real technical hurdles, but even if it's working and we're going to pay for it, we need to build them. It just takes time to build like fuel refineries and all that sort of stuff. So really, in the next 10 years in that time horizon, there's only one pathway that we can scale, and it's got a limited feedstock. And then when you look at other feedstocks, so agriculture and forestry waste, we actually need those things for other things. So the IPCC report this week has a massive emphasis on negative emissions, bioenergy, carbon capture and storage. So we kind of need a lot of most sustainable biomass going for negative emissions. And this is something the industry doesn't really think about, is the cross-sector analysis. It just assumes it can have all biomass on the planet that's going to aviation, but this is what all sectors are saying. So road transport, steel production, where do they get the carbon from? We get from biomass. So there isn't, when we look cross-sector, you realize there's actually really limited amount of feedstock, which is the graph I showed. So it's partly technology and it's partly feedstock constraints and also timescales.
Yeah, Mark has just commented, I don't think he said from lakes and algae, which I don't know, might be another source of biomass.
Yeah, so algae, has been particularly difficult and is considered further behind than others as well.
Okay, so it's another maybe long-term technology, but still not enough fuel. So,
yeah, you end up using water. You need land and water as well. And often you're better using that land for solar panels to use the energy directly. Yeah.
Okay, well, there's a lot of comments coming in saying thanks for an excellent presentation, insightful and inspiring, excellently presented. Interesting comment, putting some meat on how that green line can work as an economic model will be interesting to see. I think your last line about how you're suggesting the aviation industry should proceed, and the best talk I've heard to date. So yeah.
Great. Yeah. Well, just like a shout out as well. Like obviously our website safe-landing.org, and if you are interested in joining the group, our email is info@safelanding.org as well, which you can find on our website. So please reach out if you're interested in any of this stuff, and you just want to talk to like-minded people about your concerns. And yeah, thanks for having me. Thanks for all the good questions and for staying on a Thursday evening.
Really interesting discussion. Thanks everyone for being so engaged. Thanks again, Finlay. Very interesting topic. And yeah, we'll distribute a link to the presentation, the slides, if Finlay can send the ones over that he wants to share. And I'll give my last round of applause to, it's not quite a crowded lecture theatre, but yeah. Okay, thanks a lot everyone. I'll end the webinar now.